Okay, to start off today, we're going to finish up example B from yesterday. So this should look familiar. It's the end of the example from yesterday. Hopefully you finished it up for your homework. We were just about to do the first derivative test, so we're looking for our critical points. So I'm going to take the derivative of my f at x function. So I take the derivative of the top times the bottom, and then I subtract the top times the derivative of the bottom. So there's a chain rule there that 1 at the end is the derivative of the baby. And then I'm going to divide that whole thing by the bottom squared. So it becomes the power of 4. So I'm going to try to simplify the numerator here. When I do that, I can see that there's a common factor of x minus 1 in each of the parts. So there's an x minus 1 here and here. I'm going to pull that common factor out front. And then I'm going to write down my leftovers. So here I've got 2x plus 3 times x minus 1. And then in the second part, I've just got the 2 times the bracket. And I'm going to divide all that still by x minus 1 to the power of 4. Now this is nice because I can cancel that x minus 1 factor, and then I'll just have 3 x minus 1s on the bottom. And then I can simplify this bracket here. So multiplying out those first two brackets, just foiling and collecting like terms, and then distributing the negative 2 into the other bracket. And then collecting like terms on top, my x squared term is going to disappear. I've got 0x squared, I've got negative 5x and negative 7. Now that I have that, I can figure out where does the derivative equal 0 and where does it not exist. So f prime at x equals 0 when just the numerator is equal to 0, so where that equals 0. So then I can rearrange this and solve for x, and I get that x is negative 7/5. I'm also checking for where does f prime not exist. So f prime does not exist. And there I'm just looking for what makes the denominator equal 0. So I can see that that's going to be when x is equal to 1. Now, if you remember from our earlier work, that's actually an asymptote. So it's not a critical point, but I am still going to include it in my sign chart. So I'm going to create my intervals going from negative infinity to negative 7/5, and then from negative 7/5 up to my asymptote, and then from 1 to infinity. Now remember, this question is also asking us for those intervals of increase and decrease. So I'm just going to include that as another row in my chart. And I'm going to talk about, is my f at x increasing or decreasing for each of those 3 intervals. So I'm going to pick some number that's smaller than negative 7/5. Maybe you pick negative 2, and then some number in each of those other intervals. And then I'm just going to substitute it into my derivative. When I sub negative 2 into my derivative, on the top I'm going to get positive 10 minus 7. So I end up with a positive on the top, and then on the bottom when I plug in negative 2, I'm going to get negative 3 cubed. And when I cube, it stays negative. So I've got a positive divided by a negative, which overall is going to give me a negative. And next I'm going to plug 0 into my derivative, and that gives me 0 minus 7 on the top, so I've got a negative on the numerator. And then when I plug 0 into the bottom, I get negative 1 cubed. Negative 1 cubed is still negative. So now I've got a negative divided by a negative, which overall that tells me the derivative is positive. And then finally plugging a 2 into my derivative, I get negative 10 minus 7, so that's a negative on the top. And then plugging 2 into the bottom, I get 1 cubed. 1 cubed is a positive. So overall, this is a negative. Now remember, we did figure out that it was going to be flat here because the derivative is equal to 0 there. And then this is my vertical asymptote here. So don't forget, you can put those little reminders in so that you don't forget. What I've got here is anywhere the derivative is negative, I am decreasing on my original function. And anywhere the sign of the derivative is positive, I'm increasing. And we can draw like a rough sketch of this. So perhaps you're drawing, you've got, you're going down, and then you've got a flat spot, and then you're increasing, and then you've got a vertical asymptote in there, and then you're decreasing again. So we can kind of put this all together. I'm trying to remember, where did we leave off? Did we do we've done our intercepts, we've done our asymptotes. So hopefully you're working away on that rough sketch. But we're still going to want some nice points on our graph. So we do have our 2x intercepts and our y intercept. And remember, we found out yesterday that we were going to cross our horizontal asymptote, and that's okay as long as it on the outsides it's approaching the horizontal asymptote. So I'm going to sub in a couple of nice points. So I've got a couple more that I can add to my graph. Now I also want to figure out how low that minimum is. Remember that we figured out that we had a minimum here at negative 7/5. I need to plot that exactly. So I know that I have a min at negative 7/5. I'm going to plug that in, and that becomes about negative 0.04. So super, super tiny. All right, and then we're going to go ahead and graph that. So I'm going to grab a grid. And I'm going to graph that information. Now I know that I don't go very low on my y value, so I'm going to put my x axis really close to the bottom of the grid here. Oops. And I saw that I plugged in up to positive 3 and down to negative 2 on my x-axis. So pretty close to the center here. I want to go a little bit further to the right, so I'll move it over here. And then I can start to add my scale. Now the highest y value I had was 12, so I need to make sure that I can see up to 12 here. It should be down there. And then moving sideways, I've got lots of space here. And I'm going to place negative 7/5 on my graph. Negative 7/5 is just under negative 1.5, or I guess just over. So I've got my negative 7/5 in here. And then I can start to plot some of my exact points. So I had my intercepts, my x-intercepts at negative 1 and negative 2, my y-intercept at 2. I can also add in my horizontal and vertical axis. So I know that my vertical axis is at x equals 1, and my horizontal axis was at y equals 1. I also knew that I was going to be approaching my vertical asymptote going towards positive infinity on both sides. So I kind of have that idea in my head. You might not place those arrows though until you're sure kind of like the slope heading into that. I also have a couple other points. I know that my min is at negative 7.5 and like really, really close to the x-axis, right? It's just down negative 0.04. And then over to 2 and up to 12. And then over to 3 and up to 5. And then I can kind of connect the dots here. So this side's a little bit simpler on the right. I can see here that I'm going to be approaching my horizontal and my vertical axis. From the y-intercept here, I know I'm going to increase and get closer to my vertical asymptote. From there, though, I do need to connect these points. So I need to go through my x-intercept. Remember, it's okay for me to cross that that horizontal axis. And then I'm going to come up and cross through negative 2. And then I'm just going to continue to approach my horizontal asymptote from underneath. Sorry, my alignment's a little bit off. That shouldn't have that up bend and then down. It should just be flat and approaching the vertical or the horizontal asymptote. I'll try and do it on the computer so I can be a bit more precise. All right, moving on to example C. So for example C here, I'm going to start a new video. I will be right back.